Good morning, everyone. Thank you for joining us today. This is another one of Oasis Sales Trilogic's Did You Know webinars. Today's topic is going to be on advanced features are just a click away. Hopefully you'll get a better understanding of what I mean here. With Siemens now owning Mentor Graphics, Siemens has a very large philosophy of heading towards this digital twin aspect here, which I'll talk about more in just a second. So let's get started. Our team, Oasis Sales and Trilogic. Trilogic's a reseller for Mentor Graphics tools on the East Coast, and Oasis Sales covers pretty much the entire central part of the United States. If you're interested in any of the tools that we talked about today, you can contact either one of us by going to oasissales.com or trilogic.com and getting access to phone numbers there for contacting. We do record all of our webinars and have them available for people to watch in the future. You can go to the Oasis Sales website and click on events and archived events, and you'll see all the past ones we've done. We also have a YouTube channel available. Our next webinar, just to let you know, is going to be on March 8th. For all those out there joining us that are not using Mentor-based tools, I'm going to go over converting Altium and Cadence OrCAD designs into the paths flows for migration. And show you how simple that really is. So please join us for that one if you're interested to see how that works. As I mentioned before, all of our webinars are also out on our YouTube channel, and get access to all the past ones we've done there. Each one's usually about an hour long, but they're filled with great information on the topics that we're presenting on. So feel free to subscribe to our channel. You'll get to see when new ones pop up and any other content that we put out there. All right, so again, our webinar today is advanced features are just a click away. So let me go ahead and get started. Let me just check see if there's any questions. Nothing right off the bat there. So obviously a lot of the engineers out there that I've met in the field have been around for a while, same as myself, and start seeing a lot of new engineers out there, but even those new engineers kind of remember the old VCR tapes and stuff when they were probably kids. Their parents might have had one still, but things have changed dramatically. We went to DVDs. That was a big transition in the marketplace, and then most people get all of their content now, instead of watching movies and stuff on DVDs, they just go to online-based services like Netflix is really big, Hulu, Vudu, Crackle are all services where you can get content from anywhere you want. So over time, the things that we do every day have a tendency to change, and it's no different with engineering tools, all right? Like I mentioned before, Siemens is very big on the digital twin philosophy. They started this down this road probably 20 years ago when they bought UGS, and they've acquired several other companies along the way. They bought CD Adapco recently. And then Mentor Graphics finally filled out the entire, what they call digital twin model of being able to simulate or basically produce your product virtually from conception all the way through to manufacturing and production. There's a lot of topics here that could be talked about. We're going to be concentrating today on the product design side of this digitalization, the Mentor side of why Siemens bought Mentor Graphics in the first place, to be able to do every piece of engineering in order to verify your product design in a simulation environment and have access to that data without having to do a lot of translation using third-party tools, things of that nature, because Siemens really does own the best technology out there in all aspects of simulation. Yeah, there's a lot of competitors that are capable, but again, if you want a nice integrated flow where all the tools tie together and you don't have to do a lot of data migration, Siemens provides that platform. So that's what we're here to talk about today, how you can have access to, on the electrical schematic side of things, how you can get access to analog simulation, signal integrity, even FPGA type design data. I should have added in here actually data management as well, because the Mentor tools are going to be tying into the Siemens PLM products, Team Center as well. So it's kind of the whole data picture and engineering story that just our competitors don't have. They have pieces of it, but they can't show you everything. Where I can go right into layout, I can do signal integrity, I can do all my 3D CAD collaboration with Mcad, I can do thermal simulation, I can do electrical sign-off, DRC, take my data to manufacturing very easily, each tool being linked together without having to do a lot of data migration and having intelligent data. So the remainder of my presentation, I'm not going to bore you guys with a bunch of slides, is really going to be showing you how to do a lot of this type of stuff. So let's go ahead and get started. My main cockpit here today is going to be the PADS Designer tool for the PADS layout flow. This is the same tool, though, that if you're looking at going to PADS Professional or you're using Expedition out there, it's basically the same tool. It just has a slightly different name, but everything's the same. So I'm going to kind of start out today with analog simulation. So I have a rather decently sized schematic here. It's not huge, 20 pages or so. It's got a lot of different type of content in it, some interfaces, memory, processors, power management, but we have an A to D circuit here that is an analog circuit. Okay, many of the companies that I talked about there are using like LT Spice or some of the free simulators that are available to you, or even T-Spice was a big dominant factor there at one point. But it seems like pretty much everyone uses LT Spice that I talked to, at least the small companies. You and larger companies probably have a more mainstream capable simulation engine. But from PADS Designer, we have a tool called PADS AMS. It's basically, it mentors analog engine from System Vision. It's also going to be changed its name to Expedition AMS, but we have a PADS AMS version that is now included with our tools. The advantage here is I can capture my schematic as if it's going to be transferred right into a PCB. I don't have to put elements in the schematic. Like, you don't see any power supply nodes in here, source nodes, anything of that nature. These are all physical components that are going to go right into layout. So here's a A to D circuit. It's got a part number in it. It's got a footprint associated to it, so that I can go right into layout. I don't have to mess around with this third-party tool or removing data in order to transfer this information into PCB. So I'm doing two things at once, basically. Again, fitting into that digital model of being able to do everything and then simulate it and move on to the next phase. If you're a PADS customer and you didn't realize you had this tool, if you're a PADS Standard Plus, if you go to licensing, you'll see the PADS Hyperlinks Analog or AMS options here. You just need to check that box to make sure you're checking out a license for that. But once I've captured all my content, and the nice thing about the PADS AMS that many of our competitive tools like T-Spice can do to some extent, but not as fully based on industry standard language anyway. We can use T-Spice models for everything. We have a conversion tool. If I go to simulation here, I can do convert, and I can convert any of my T-Spice models that I have today over to our format, which is just slightly different. I can include VHDL models. So our simulator supports VHDL AMS, which is an analog or analog version of VHDL. In fact, if I click on this part here, and say push VHDL, you'll see I have a VHDL model for this A to D converter for use during this simulation. Okay. For my analog parts, I'm just pointing to splice models. For resistors, you can set up specific models if you want, or you can go a little bit more generic. You can even go into detail where I set up a VHDL model for that resistor. If I want to do something a little bit more detailed in that space. Another cool feature in here is if I don't have a model for something, I can actually use a model wizard that we provide that can base stuff off of a SPICE model or VHDL AMS model, or even a schematic if I was going to go that route, and I can create kind of a model on the fly, which again, not many of our competitive tools have that capability. So I'm not going to spend too much time in here. This isn't meant to be an analog demo. I just wanted to show that I can capture a schematic in here. I can go obviously set up my simulation process that I want. I can start the simulation right here from Paths Designer. Tell it to run. This will take about 20 seconds or so here to run. And then it will pop up the data for me in a Waveform Viewing tool. And I'll just show a little bit of interaction between the schematic and the PCB. If I've got the simulation results, I can see the results here, and I can click on nodes, or I understand the schematic a lot more, and it's easier for me to probe from within here. I can select a net and say plot waveform, and now when I go over to that should have. Well, that's not working, but that should have launched, selected my signal here, and opened it up for me. So I can look at, there's my output waveform. I can look at my input waveform. I can add cursors in here. The Waveform Viewing tool is more than capable. It actually comes from our high-end analog simulation tools for IC on the Mentor side of things. So again, this isn't really meant to be a hyperlinks analog demo by any means. I'm just going to discard this. Yeah, I just wanted to show you that you can work in a fully integrated environment in your schematic and take this data right into PCB without having to do a lot of modifications for the purpose of the analog simulation part. And we can do advanced things like the VHDL analog simulation functions. Along those notes, if you're doing any FPGA stuff out there, you can also link in VHDL code to your symbols in the tool, and you can compile all of your VHDL data right from within DX Designer, and you can launch the tool from in here. So I'm just going to click on this part. This happens to have it, but if I did have a IC in here that had VHDL code under it, I can click on that and tell it to launch Model Sim in this case. But if I go to my setup here, I can also tell the tool to launch any integrated tools that I might be using, like the Xilinx tools. If I'm using Altera for simulation engine for some reason, I can tie those applications into here via settings. And again, when I right click over something, I could launch my FPGA tool right from my schematic. So if you're an engineer, you're typically driving stuff from here, at least the do-it-all engineer, where you're also doing the code itself. Maybe you do have a separate group doing the FPGA side of things, but for that do-it-all engineer, you can work from one environment and manage your content and start your simulations from that perspective. So FPGA stuff, again, it can be integrated as well. Again, think about the tools you may be using today. If you're not using, the pad flow applications, how difficult it can be to manage and take care of, analog simulation and digital stuff, FPGA, things of that nature. So Let's move over to the PCB now. So from the schematic here, I can launch my PCB application and go into my layout for this design. Make sure I don't have any questions that have popped up yet, not so far. So, here we are in the physical layout for this design. The first thing that I'll show here is is obviously Mcad Collaboration. So if I bring up my 3D view of this board, I can have all of my 3D content obviously stored off into my library, so I can do 3D placement in the PCB tool. But what's more importantly, and that I still see a lot of customers not doing today, is being able to collaborate with your mechanical engineer on a more of a real-time basis. I'm still hearing a lot of customers that are using BXF files, drawings, things of that nature to place, critical components like these connectors in here, the mounting holes. All of this data can be obviously transferred electronically from the Mcad environment into the PCB, so you're not wasting time looking at drawings, possibly getting something wrong, maybe outputting a step model of the board so that you can take it back to, the mechanical engineer for him to verify stuff and then tell you, oh, this part has to move here or there. Being able to import the board outline, critical components, they can place all of that type of stuff in their Mcad tool, and you can bring it in here. And then once you're in the 3D environment, you can, obviously place components around, the 3D aspects of that design. Look for clearances, being able to do DRC checks. If I can measure data here, so I can measure stuff, between, say, this surface of this part and this surface of this part. I can get a distance on that, but I can also bring up or set DRC rules where I can actually do dimensional DRCs right in my 3D environment. Okay, but more importantly, I want to be able to collaborate with my mechanical engineer. So from my 3D view here, I can launch our collaboration tool and I can output data. If I start the design, I can output the entire board all at once and send it over to them. Or the whole purpose of collaboration is being able to do basically ECO or engineering changes between the PCB and mechanical, just like you would in a schematic. If I add a resistor to a schematic, I can just update my PCB real quick. Well, the same thing can happen on the mechanical side. If the mechanical engineer decides he wants to add a mounting hole here in the middle, or he changed his case and he needs to move this connector, and he has this PCB model in his design, he can move that part. Even though I've started the design already, he can send me a change request via the collaboration tool. I can view that change in my collaboration tool or in my 3D environment. It'll give me a ghosted image of where that part's moving to. And then I can decide if that change is good. Maybe if it moved into this fiducial, maybe I have to move that fiducial somewhere else. I can see what the conflicts are before I accept them. But using the collaboration tool, I can then accept that change. I can put in a note here, and I can choose the accept or reject options here. If I reject the change, I can move the part to where I think is acceptable for my assembly and see if he can modify his mechanical around my requirements, and I can send that change back to him, and we can collaborate back and forth in more real time instead of having to either go into a meeting or deal with drawings and things of that nature. Okay, so again, doing stuff electronically is definitely becoming more of the wave of the future, and if you're not doing this, you should really consider including this into your design methodology moving forward, so you're designing faster and more accurately. Let's go ahead and close out of there. Some other things that I can do here is I can go into some of our other simulation applications that you might have design issues with, like you're worried about signal integrity. Okay, I can launch this design into our signal integrity tool so that I can do simulation on either nets that I've launched up front, which I completely forgot to show. Let this go ahead and launch, and I'll show up more on the schematic side. But typically, before you go to PCB, if you have critical nets in your design, you're going to want to do some type of pre-analysis on those particular nets, especially if you're doing any DDR stuff, high-speed, gigabit interfaces, even something as simple as a clock net, or even a multi-drop data or address bus line. You might want to look into. So let me go back into here, and we'll just select a net like this DSP output here. Now let's say I'm worried about this line in my design for some reason for signal integrity. Right here in the schematic, after I've captured this, if I've assigned IBUS models to my part here, which I haven't in this case, but if I did, when I right-click over this and say I want to take this into our pre-schematic environment, what I can do here is I can see the topology of this net. This is a multi-drop. Actually, it's got 2 nets on it, connector and a couple of resistors. But I can launch this right into our what-if analysis environment for signal integrity, so that I can play around with a stack up in here. You know, what does my stack up need to be to begin with? I can play around with this and that in this environment, but I can also look at, you know, how long these traces maybe need to be. Do I need to have a terminator in here, or an AC termination scheme, DC pull-up, something like that, and simulate that. I can even simulate, you know, if there's a via in here, or if there's going to be multiple vias, I can add those in and see how those are going to affect my simulation, all in a pre-environment, so that when I get ready for PCB layout, I can have all this information entered as design rules. Okay. So again, from our schematic tool, I can go into our design rule environment, and I can take those rules that I've defined via simulation if I want to, and I can come in here and I can set up, you know, my nets and classes. I can add virtual pins, max number of pins. I can put link matching information, all at the schematic level, so that when we get into the PCB space, everything's ready to go, and I don't have to play guesswork or produce the design and have to do a prototype in order to check my critical signals in my design. So what I was showing on the PCB side was basically the same thing. Let's go ahead and exit out of these here. Once I've got my PCB started and laid out, I can come in here and I can say click on a critical net, like say my DDR net here, and I can simulate that. Even though I verified it in maybe ahead of time in the schematic, you still need to do verification, because your routing, you know, may not be 100% exactly what you would expect it to in a what-if environment. So in here, I can still come in and we've got some models assigned here. Let's make this the output. I can still come in here and do a final verification as if I had the board sitting there right in front of me. Again, I'm simulating this to ensure that when I go produce my very first design, I'm not having, I don't find any errors. So once I'm in my simulation tool here, I can go ahead and start a simulation on this. Look at the signal integrity of this net. You know, do I have too much ringing or overshoot? This one happens to be good in this case because the line is so short. But a lot of times, you know, the net may be too long, or I have multi-drop DDR, where I have vias. You're going to see a lot of reflections, and you'll have to play around with maybe adding some termination or changing the termination schemes on your DDR chips if you're using DDR4. By the way, Hyperlakes has the best tools in the industry for automating the process of dealing with DDR channels using our DDR Wizard application. That can be used. And of course, if you're doing any high speed stuff, you can get into all of that as well with Hyperlakes. It's pretty much the leading tool in the industry for desktop engineering signal integrity analysis. So again, I'm not here to really go into a lot of detail on this, but being able to simulate directly from my layout tool and not having to do any data migration from another application or into another application just makes this process that much easier. Okay, I'm going to go ahead and exit out of here. Now let's say I wanted to look at some of the power planes maybe on this board. I can again go to analysis and I can go to DC drop, and this will again launch the design into the Hyperlinks tool. But now I'm going to be looking at the power planes and doing analysis for, do I have any bottlenecks in my planes on this design. So this was a little bit, some people may call this a complex board, some may not. It just depends on what level designs you're doing, but this is a reasonably decent board. It's got couple big chips, some high-speed stuff in it, lots of different power planes. But again, the idea here is to be able to select a given power plane and do a verification on it to make sure that I either have enough vias or copper coming off the source power supply into the plane, and then I don't have any plane bottlenecks. As you know, when you get into BGAs, or if you got lots of stuff on a board, you can end up bottlenecking yourself in some of your plane areas and causing DC drops. So basically, I may be starting with 1.8 volts, but by the time maybe I get over to this part here, because I've cut it off so much, I'm only actually getting like 1.5 volts. And with your margins for power supply and noise, that may be causing problems with those parts over there. So being able to analyze your power planes for DC drop is becoming more and more critical today, especially if you're doing any complex type designs. Again, I'm not going to go into a lot of detail on this. We have some webinars that touch on all of the topics of these tools that I'm showing here. I'm just showing more of what some of the capabilities are of integration with the tool flows you may have if you're a Mentor customer, or you could have if you became a Mentor customer. So what I'm talking about here are a lot of the strong points of where the Mentor tools differentiate over our competitors, say Cadence or Altium. They have some nice tools in certain areas, but it doesn't complete the full engineering picture, especially if you're doing anything a little bit more complex. Okay. So next, I can a little bit more in the analysis space. I can, again, if I'm doing DDR like I am here, I can go to the DDR analysis. That's just going to open hyperlinks like I did before and take me into that space. We also have two types of thermal simulation that we offer. We can do a basic, just a printed circuit board simulation where I can analyze the design just from a perspective of this part's getting hot. How can I play around with some stuff on the board like stitching vias, copper areas, things of that nature to help cool that part, maybe put a heat sink on that part. It will understand a little bit of airflow stuff as well, so it's a very simple tool to use. Pretty much any engineer out there would be able to pick up this application very quickly and be able to simulate with it. It's like I said, it's very simple to set up. The models for it are very quick, simple, and easy to deal with. Once you have the environment set up, again, you can run a simulation. The simulation engine's extremely fast in checking your design for you, but then it'll give you a heat map. This wasn't a very good example, unfortunately. Heat map of where the board is hot and cool, and then you can play around with putting stitching vias in. I can add heat sinks, heat pipes, thermal vias in there, re-simulate again, and see if it assists with my cooling. Now, if you want to go a step further, aside from this basic just PCB related simulation, you can use one of our FlowTherm tools. Again, we're integrated in. In this case, we offer FlowTherm XT for pads and also Expedition, but there's also Flow EFD if you're doing mechanical design that can do thermal. And if you want to get into great detail on the physical PCB itself, there's also FlowTherm that just goes into a lot more detail and can do things that FlowTherm XT can't, but the XT is basically a subset of that application. Unfortunately, my licensing for some reason is not working for this tool, so I can't necessarily show that, but what I can do here real quick is show a quick little video of that tool for those that haven't seen it. But again, all these applications we've done webinars on. You can get more information off of our website for doing that. So let's go ahead and get into this video here. This is presentation. That was more just presentation. These may be more presentation based. This is talking about the meshing capability in the tool, that the tool takes care for you automatically, so you're not having to spend a lot of time doing the meshing process in the design. The whole idea behind FlowTherm XT is that the average mechanical engineer or electrical engineer can do this type of simulation. You don't have to be a CFD expert to go in and do more detailed thermal simulation on an entire case with a fan blowing on it, different types of heat sinks, environment. So again, it's to make the do-it-all engineer or the non-specialized engineer to be able to do their own analysis and for thermal simulation. So let's see, let's go back here. The last one I wanted to show here is the DRC. This is becoming bigger and bigger in the industry. Mentor's the one that really started this philosophy of being able to do electrical sign-off verification on your design. Many of the things, and pretty much everything this tool can do, are things that you typically have to do in a via manually. Okay, so everything in here that you would do based on these design rules would be manual inspection. So there's some EMI design rules in here, looking for like nets crossing gaps, vertical reference plane changes, if you're doing really high speed. There's some PI design rules in here. There's signal integrity checks that you can do in here. If you're doing a lot of differential pair, the tool can check for, when a differential pair changes layers, do I have ground stitching vias next to it so that the ground currents will flow with the signal through the reference planes? Do I have decoupling capacitors? If a reference plane changes from, say, ground to a power reference plane, you need a decoupling cap in there to offer the ground current path. Do I have stubs in my design? There's, I think DRC is up to 37 rules that can be, that are enabled. We have different flavors of this application as well, but no one in the industry really has an application that can do this type of electrical sign-off or verification on your design very quickly. So what I'm going to do here is I've turned on nets crossing gaps. I'm going to let it go ahead and execute on this design. You'll see here the tool has built-in help that's extremely useful. Gives you complete visibility as to what what the issue is or what that rule is doing and what it's searching for. If you want to get into real detailed electrical sign-off, we have versions of the tool where you can actually write your own design rules. There's a lot of vendors like Altera and Xilinx that are really coming on board with this application, and they're actually writing rules for you for those people doing a lot of high-speed gigabit type things. So let's go look at some of the violations here. I can click on there's a net crossing a split in the plane. Now, is this critical? It may or may not be. That's one of the things I can do in the setup for this is I can define what nets I maybe want to group or check for nets crossing gaps. I don't necessarily want to look at everything like I am here. So this net may be a DC net. It may just go to 3 volts or 2 volts and stay there. It's not really switching. Or I know it's going to switch at a very low edge rate, like 10 nanoseconds or a microsecond or a millisecond or something. Then I'm not worried about it. So you can set up, in the process of using the tool, I can set up what nets I really want to verify for any one of these classifications of design rules. But being able to have a tool that automatically goes out and verifies your design for these types of EMI or PI or signal integrity issues just speeds up the entire process of doing a design. These types of checks that this tool can do are things that signal integrity tools typically can't do or have a more difficult time doing, which are these geometric visualization type verification capabilities. So again, the idea here is that from either my schematic or my PCB main tools, I can get into any of the verification functions that I might want to do on my designs, either from the physical PCB world or from the schematic world. Being able to get to my FPGA analog simulation, doing signal integrity analysis without having to worry about launching some tool from a different vendor, worrying about translating that data into that design, or God forbid, going in and capturing an entire circuit in a different tool altogether, and not being able to use that content moving forward. Here I can do everything in one environment, simulate it, and move on to the next phase of my design. By the way, for those out there that are using, say, PSpice or LT, Mentor is adding the capability of our tool to use those engines. Sometimes you get models for those engines that are encrypted that you may not be able to convert and use with our simulation engine. We are going to be offering the ability to, say, for this circuit, if for some reason I have encrypted models on here for LT, I can use those and then capture my schematic in here, and I can actually launch the linear spice or the LT engine from my schematic tool, let it simulate, bring the data back in and view it in our Waveform Viewing tool. So you still may be able to use, or you still can use your third-party applications if you're tied into some type of models that you just can't get in different formats. So very flexible environment from that perspective. So. All right, well, that was a quick rundown of being able to design from one environment and launch into all of your simulation tools. You may have learned about some simulation applications that you weren't aware of previously, like the thermal, maybe, and if you're not doing signal integrity, some of those. Some may not realize that you can do analog simulation inside of PADS Designer. Let us know if you're interested in these applications if you don't have it already, or if you do and you just want to learn a little bit more about it. Please let us know. We're here to help you transition and use these products that you've purchased from us. So that's basically the end of my presentation today. Let me check and see if we have any questions out there. Nothing seems to have popped up so far. So again, some of the common things that we do hear from people is, on the PCB side, we do have some people using IDF, but IDF, which we do support, I can import IDF files into the tool to generate the board outline and some placement stuff, but you can't really collaborate still. So as I mentioned earlier, if something needed to change, that change has to happen manually, where with collaboration, that becomes a much more streamlined process. So, if you're not doing that today, if you're using drawings to place parts and draw board outline, stop, using that method and looking into using IDF or using the 3D functionality within our tool to make this process a whole lot easier, dealing with placing components and such. But another question is being able to export 3D data from our tool with model information. This is supported now, so I can export out a step model of this entire board with all of the step models included. It actually comes over into the Mcad tool as an assembly, which is kind of cool. Again, it's very static, so it's not real-time collaboration function, but being able to export this board with all of these components, bring it into my Mcad environment and have all the models there, and then being able to move them around or save the models off to their library even, is pretty powerful, because as an electrical engineer, you may take the time to go off and find these, and the mechanical engineer doesn't want to do it, so you can, basically give them to him via, exporting out to a step model. Okay. All right. Well, I don't see any other questions, so I'm going to go ahead and wrap it up for today. I want to thank everyone for joining us for this webinar. Hopefully, I've introduced you to some new technology and capabilities that you haven't been aware of that could speed up your design process. Feel free to mention this webinar to any of your colleagues. We'll have this posted on YouTube here in the next day or so. They can come out and watch the webinar and see the capabilities that we have to offer. So again, I want to thank everyone for joining us today, and come back again on in March for our second webinar on translating designs from Altium and pads. So, I just had a couple questions pop in here. Are the tools in pad standard? No, many of the things that I mentioned in this application are not in pad standard. They're part of standard plus. Some of them are add-ons to either one, like the Thermal Flowtherm XT. That is an add-on application. Hyperlinks DRC, Hyperlinks DDR. Those are add-ons even to standard plus. Okay, well, thank you, everyone. I'll go ahead and end the session now, and look forward to seeing you back again.